It only exists, sum to infinity only exists for a geometric sequence. Okay? And R must be less than 1. Actually, R must be between 0 and 1. All right? So it's got to be a fraction. If it's 1, if R is 1, we are getting the same number again and again. So if we've got 2 and R is 1, then term 2 is 2, term 3 is 2, term 4 is 2. But once we've gone smaller than 1, we are actually starting to shrink it. So if we could sum all of the numbers of a geometric series up, every single number, there is a number with these two conditions, that it's geometric and that R is fraction, where the sum will never actually get to, but it actually is it. Because we're adding on such a little weeny teeny number that if we rounded it would be it. Okay? And the formula for this we write as, not many places in maths that we write an infinity sign, even though we think of it as mathematical. All right? The formula for this is that S of infinity, the sum to infinity of a sequence, is the first term divided by 1 minus the ratio. The ratio has to be a fraction. So if we look at this sequence, so let's say 10, 5, 2.5, 1 3/4. All right? What does that add up to? Just those first 4 terms. What do they add up to? S of 4. So that's 10 and 5 is 15, 17.5, 18.5, 19, 19.25. All right? What's the next term going to be? Half of 1 3/4. 1.75 halved. Half of 1 3/4, that's 7/4 is 7/8. Oh, that's not a half, is it? Come on, guys, you're not helping me here. 17, 18 and 3/4. Right, so the next one after 1 1/4 would be 5/4 halved is 5/8. Right, and we'd be adding that onto that, etc. So, from even the first 4 terms, we can kind of see where this is going. Where do you think that sum to infinity is going to be? What number do you think, no matter how many of these we add up to, we're not going to get to?
0.
We're definitely not going to get to 0 because we start by adding 10. 10 plus 5 is 15, plus 2.5 is 17.5, 18 3/4, plus another 5/8, so we've just gone over 19. Then we're going to add 5/16, which is really tiny, then 5/32, which is even tinier. We're not going to get to 20. Let's test it out. So it says if we continue to add forever, what won't we get to? 10 minus 1 times a half. So 10 divided by a half. This is one of those questions they quite often have on Facebook and things. Divided by a half is multiplied by 2. All right, put it in your calculator though, make sure you get it right. You're not dividing 10 in half, you're dividing by a half. So you're saying how many halves are there in 10? All right, so that answer to that is 20. We could have trickier numbers than that. So we could have numbers like 56, 42, 31.5. dot, dot, dot. All right, so if this was our sequence, and that's all we'd been given, and we have to find the sum to infinity, first thing we have to do is find A. All right, so A equals 56. Next thing we have to do is find R to test that it's between 0 and 1, or a fraction. So to find R, we use one term divided by the next one. Find out what that is on our calculator. So we put 42 fraction. 56 is 3/4. We test it with the next one as well. So is that the same as 31.5 divided by 42? 31.5 ABC 42 equals 0.75, 3/4. So tick, R is less than 1. So therefore we can use the formula A over 1 minus R, 56 over 1 take away 3/4. What's 1 take away 3/4, guys? One pizza take away 3/4 of a pizza leaves how much of a pizza? 1/4. Good. And as I said before, that's not divided by, that's not a quarter of 56. It is 56 divided into quarters. So that's an awful lot of pizzas, right? So we're actually multiplying 56 by 4 when we divide by a quarter. 224 is what that sequence, if we continue to add it up forever or for however long we like, we will get to the point where we're adding so little, it looks like 224 when rounded. It's only going to get to 223.999999999, but we round that to 224. Okay?